Is there a Class B GFCI? There is not a Class B GFCI. They just ended up skipping right from Class A to C, D, E, as far as I know. The difference between a GFCI and a ground fault equipment protection, for like ground fault equipment protection is more in line with tripping, but you don't have to follow like an inverse time curve, whereas the ground fault circuit interrupter, it's looking to follow a certain trip curve. So I would argue that ground fault equipment protection is looking to just trip the system within a second or less, but it's more definite time based. What ground fault equipment protection is needed for electrical heat trace circuit? Do you have a device for 30 milliamps? So we do have a device for 30 milliamps. I'll have to check back on what is used for a heat trace circuit, but I believe it should be at 6 milliamps. How to ensure protection coordination between GFCIs? I don't think it's something that you just coordinate with. You just have to follow the inverse time curve. I'd have to double check on that to see if coordination is possible between GFCIs, but overall, I'm not 100% sure on that because you have to follow that inverse time curve. Maybe we can make adjustments to be well within the inverse time curve and make it faster than it, but I'd have to double check on that. Do you offer other ampacities other than the example, let's say at 60 amps? So for the 60 amp one, we would just use our 100 amp variant, and we would recommend applying fuses at 125% of the rating upstream of the panel that we provide. How often is calibration needed for your devices? For the most part, probably just some yearly maintenance, maybe just making sure that the breaker's non-sticking. Aside from that, maybe pressing the test button a few times throughout the year during downtimes. Is there a I-Gard part number for the ground fault protection panels? So we have 4 different options. We have GPD, which is our 100 amp circuit breaker, and that has a range between 5 milliamps to 35 milliamps. We have GPAD, which is used for ungrounded system, and that can trip between 5 milliamps to 35 milliamps. We have GPFJ, which uses the 225 amp breaker, and then GPAFJ, which uses that 225 amp breaker but is suitable for an ungrounded system. We are in an offshore environment and looking for ground fault equipment protection at 30 milliamps. So if you have a requirement for ground fault protection at 30 milliamps, and let's say your circuit breaker is shunt trippable, I would recommend going with the M-Gard 10C1, which has a low level trip between 10 milliamps to 6 amp, and I would use that to pick up the ground fault and send a shunt trip command to the shunt trippable breaker. If you don't have a shunt trippable breaker, then we can provide our ground protection panel, and that would be reaching that 30 milliamp range. So you always employ a 30 milliamp GFCI on heat trace. Okay, awesome. What is the recommended frequency of the trip test button? I think it's site dependent. Some people I know do it once every 3 months, but I'm not sure if there's like a recommended time. Maybe during every downtime, it's recommended to do a test to make sure everything's working as it should. But the actuation of the breakers, maybe that can be done annually or semi-annually. Our panels are, it's one of these two, UL or CSA. I forget which one, but I think it's CSA, and we have UL508, but I'll have to confirm. Same category GFCI despite of milliamp rating and series trip together, so if near load is general purpose and backup to be followed by delay type like S type, am I right? We'd probably have to examine that on a case by case basis, but if you're imposing a delay, it may not meet the inverse time curve. Do you have electrical schematic for the GFCI and how I can connection with electrical loads? We do have, it's a very basic schematic like the one I showed you in the presentation, where we just have a ground fault relay, a CT, maybe some control transformer, some pilot light, and then we'll also have the circuit breaker. Is UL943 applicable in Canada? Right now we're using UL943 since there's no other thing that covers this. The closest thing that we have for CSA is in the 144.1, but that only talks about the 5 milliamp, not the 20 milliamp. So most people in Canada just adopt towards UL943 to figure out what they're going to do. Do your offerings have UL listing or recognition? At the moment, we have UL508 at the moment for industrial control panel design. We're going to be looking for UL943, but UL943 isn't really a certification. It's more like, it's not a standard yet. We're working with UL to figure out what standard we would be falling under for this one. We already know we have to confirm conform with UL943, but it's not yet a standard. So we're figuring out which certification we need to go through for that one. Can you define the let go option of the GFCI? It's the capability to be able to let go from the shock that is being experienced, because sometimes there's a holding effect that occurs when you get electrocuted and you may be paralyzed and stuck in holding that affected equipment, which could be problematic. Can these be integrated into motor starters and motor control centers in lieu of installed in standalone enclosures? We have offered backplate options before, and we can do that again. Our current panels at the moment are certified to CSA 144. On the table, you showed two numbers. Is the above is trip rate, the below is frame rate? Are you talking about this table? So the trip level is defined here. The voltage is here. Note that this is the line-to-line voltage depicted, because for a Class A unit, the unit has to be at 150 volts or less. So for a 208 volt line-to-line system, you're going to have less than 150 line to ground. And then the ampacity of the breaker is indicated here on this portion of the table. You mentioned the neutral, where present, is also monitored by the CT. Can you expand on the neutral conductor current, how current on the neutral is read? So going back to the slide here. So if we have a 3-phase 4-wire system, the current going into the single-phase load would be the current going out through the neutral wire. So this zero sequence CT in normal operation will not pick up anything. But when you have an imbalance in current, that is typically picked up because the current is going in, but it's not coming back on the neutral. And as a result, we can dictate that there's an imbalance. Typically, these CTs would be wrapped around the 3 phases and the neutral, where if in normal operation, we would have 3 of the phases dishing out the current and then the neutral providing the return path for the current, where the vectorial sum will equal 0. So those are the various different variants. Are there wiring diagrams available for installation? Yes, we do have some wiring diagrams and we can share them with you. We do have 2 different variants for our panels. We have grounded configuration and ungrounded configurations. In the panels that have ungrounded configuration, we basically use this resistor setup within the panel to limit the fault current and also pick up the fault so that we can trip it. Any standard to dictate to use GFCIs as mandatory in commercial and industrial sector? Aside from what I've indicated in the presentation, there's not really much else in terms of what dictates this. You can look at 144.1 in the CSA, which mostly talks about 5 milliamps, but more times than not, a lot of Canadian consultants have to use UL943 as a guideline basis. 1 phase 3 wire supplies. Yeah, because I would imagine that one is a hot, there's another neutral, and then a ground. So the ground would be outside of the CT and we would just push the line and the neutral through. I hope that answers that. I don't know if there's a different 3-wire system that I'm not sure of. Oh, 2 hot and neutral. Yeah, we can do that as well, where it's like a load that's fed by line to line instead of line to neutral. We can accommodate for that as well.